Welcome back to our ongoing series of videos in which we're learning how to create an RPG game. In this lesson, we will have an introduction to finite state machines. Ooh, it's another one of those terms that sounds super cool, super complicated, but actually is kind of easy to understand. But boy, it'll be great. You can tell people, yes, I learned about finite state machines today. All right, so what does that mean exactly, and how are we going to use it? Well, where we left off in our last lesson is we now have our player able to cruise along and animate correctly through our room. But what if I wanted to make it so that our player could attack an enemy? Right? Up to this point in our class, what we have done when we wanted to perform some different kind of action is we made a lot of use of if statements. So, like, for example, if we wanted in our platformer to have our player fire a weapon, then we would say something like, if fire key equals true, then create a bullet and fire the bullet. Or if we wanted our player to jump, if the player hits the jump key, then jump up. So as your games become more complex and there are more different types of things that you want the player to be able to do within the game, or an enemy or some other object in the game, it can get a little unwieldy to start doing a whole collection of if statements. For example, if the player is jumping and the player is shooting, then jump and shoot. Or if the player is falling and wants to roll, then fall and roll. And so that you can see that pretty quickly the ifs can keep adding up and adding up and adding up. So an alternative, sort of cleaner approach is to create a finite state machine. And what you can do with a finite state machine is create different conditions that are self-contained, that represent the different states in which your player can exist. And then what you do in the game is that you switch between those different states. So it sounds kind of like if statements still. But it's much simpler because if you design it correctly, each state is independent of the other states. And so that if you want to modify something, you can just go look into that specific state, make changes to it, and don't have to worry about hunting through all of your code to find everything else. It also simplifies the if challenge, where you don't have to have quite as in-depth collection of if statements. All right, so let's pursue this a bit by creating different states for our player. What we're going to create for now is we're going to have a move state and we're going to have an attack state. So how are we going to set those up? Well, if I go back into my game, and let's grab our player object and go into our create event. And in our create event, I'm going to create another enumeration like we did with the directions. I'll put it here. And this enumeration is going to record the different kind of player states that we have. So in fact, I'll use the enum keyword and I'll call this one player. And in it, I'll list out the states that we want. I want a move state, and I want an attack state. And we may add more later, but for now we'll start with these two. Okay? All right. Well, that doesn't do anything, right, other than name some states. Okay. How do I make use of and move between the different states, this move state and this attack state? Well, I mentioned that the idea is that we want to create independent conditions that contain all the code needed to perform all the actions that exist within that state or that condition. In GameMaker, we can make use of a cool feature they have, which are user-defined events. We've been using create events and step events, collision events, all of these built-in zillion different kinds of events. But the way I'm going to set up our finite state machine is to use, down under Other, user events. And you can see under user events there are 16 user events that I can define for a given object. And that's plenty. And what I want to do is I'm going to couple these user events with the underlying value that is associated with move and attack in this enumeration. Basically, move is 0 and attack is 1. So I'm going to create a user event 0, and this is going to be my move state for my player. Okay. Under the description, I call it move state, so it makes it easy to see what's going on. And what is it I want to have happen inside this move state? Well, currently, we are taking care of all of the input and doing all of that kind of hard work here inside the step event. I'm going to take all of this stuff out of here. All of it. Except for this sprite index equals sprite direction facing, the thing that shows the correct sprite. I'll leave that in the step event. But all this other junk I'm going to copy out of here, and I'm going to paste it into my move state. Okay. There we go. Just works the way it is supposed to work. Okay. I'm just checking, is there anything really that I need to change in here? Don't think so. That all looks good. That looks good. No, that's pretty much it. So we just moved it all out of the step event and into our move state. Well, how exactly do we get into that move state? Well, back here in our create event, what I can do at the very end of all this other stuff is I'm going to set initial state. And what I'm going to set it, I'm going to create an instance variable called state, and I'm going to set it equal to player.move. Just like that. So what will happen is in the create event, it'll set up all this stuff just as it is now. Then it will instantly move into the move state, and it will perform all of this stuff. Okay? Well, that's fine. It'll move into the move state and it'll perform all that stuff, but because it's in the create event, this is only going to happen once, right? It'll be move state, and actually doesn't even do that, right? All it's doing is just saying we want the state to be player.move, which is another way of saying 0. But that doesn't actually cause us to perform this move state. So what do I need to do to get this to run? Well, now I'll come into my step event, and I'm going to say event user. This is a built-in function in GameMaker that will run whichever of the user events I pass to it. And which one do I want to pass to it? I want to pass whichever one represents the value that's in state, which is currently player.move, which is another way of saying 0, event 0. So each step it's going to run this user event. I wonder if you can start to see the value of this. We're also going to have an attack state, and so when we get to that point, I'll create an attack state here, add all the code into it, and then we'll figure out a way to get us to switch between the move state and the attack state. We don't have to do that yet. Let's just start with what we've got here and give it a give it a try. It should run just exactly the same way as it did before. Okay, we can go left, right, we can go up, we can go down. Everything works just as it should. But you'll see the code's a lot cleaner. Now the step really has nothing going on in it other than just switching between states, and then the states is where all the action takes place. And if we need to modify it, we just come into this move state. We know where things live. Very nice. Before I leave this first introduction to finite state machines, I want to do something else while we're here. Out in our scene, we have these bushes, as you can see. But the bushes are kind of weird, right? I walk right underneath them. It's not a great look. I'd like to change that if I could to make it look a little bit better. And while I'm at it, I've got a weird issue with my player. If I come over here, I can get stuck. See how he's stuck there? So we're going to do a little cleanup to fix both of those things. Let's start by cleaning up our player so that the player doesn't get stuck. So if I come down into my player sprites, the one that I'm setting as a default is player run down. And the reason it's getting stuck relates to its collision mask. We, in our platformer, were careful and learned about the idea of setting the collision mask for your object to a single collision mask, regardless of which sprite you're using. So our default sprite is the run player down for our object player. So in the object player, what I need to do for the collision mask is to say I want all, no matter which sprite I'm using, I want them all to use the collision mask associated with run player down. Now in doing that, I should eliminate that weird issue where we get stuck in the corner. Now I can come over here, come down, and hooray, he no longer gets stuck. But there's another thing. It's not really an issue, it's more of a visual thing I'd like to change. You can see when I'm down here, my player comes up against the wall, which is fine. It's a little weird to think about given that this is supposed to be top down, that he's sort of up against the wall like this. But if I come up here, you can see he gets stuck. Or he doesn't get stuck, but he can't move any closer to the wall than his head, and that's because the collision mask is covering his head. So I don't want that. I'm going to come back into my sprites, back to the run player down sprite, come to the collision mask, and we're going to manually set this. And what I want to do is I'm going to have the collision mask cover just down to like here. Okay. So you can see it comes down and it doesn't cover his head. So now if I come in here and I walk up to there, you can see, oh, that looks nice. Now I can sort of walk closer to the fence. Okay. You can play around a little bit with it to get it to look just the way you like. But for now, I think that looks pretty good. Okay. There's still a weird issue here too with the way that our player is interacting with the shrubs and the bushes. So let's take care of that. The way I can do that is the following. We're going to do an initial version of a fix for that visual sort of, it's not a glitch, it's just kind of a weird view. And then if time permits, I'll do a more robust fix later on. All right. What we want to do is for our player, as our player is moving around on the screen, I want to alter the depth at which the character is drawn out into the room. If I come into the room itself, you'll see here I've got a collection of layers: greenery, player, pickups, enemy, walls, wall tiles, paths, and background. Within a given layer out here, I don't really have much on the player layer. I've got a player. I don't remember if I have anything else. It's not letting me see it very well. There we go. Got a camera, the player, I guess probably have the control object as well. And within this layer, each of these objects is going to be drawn at a certain depth. And in fact, each of these layers is going to be drawn at a certain depth. And if you look down at the properties, you'll see the greenery is drawn at depth 0, the player is drawn at 100, 200. So as I come down in the layers, the depth is higher, if that makes sense. What does that mean exactly? It means that things that are lower in this list of layers are going to be drawn behind things that are higher in this list of layers, and that's reflected down here in depth. The higher the value of the number of the depth, the farther sort of back things get drawn, the lower they are in the pile. Okay? And within a single layer in my room, if I have multiple objects, the thing that's drawn first gets drawn sort of behind the other objects. Okay? Now what I want to have happen is that as my player moves up the room, I want to change the depth so that as the player moves up, it's going to be drawn behind things which are lower in the room. All right? One more time. As the player is moving up the room, I'm going to alter its depth so that it is going to be drawn behind things that are positioned lower down in the room. This won't work all the time, and we may fix it later on, because if you have a really big room, like a really big room, eventually you could run into an issue where as you move farther and farther and farther up the room and you're changing the depth with the system we're going to use, you could ultimately have issues where it doesn't draw in the correct order. Okay. So how do I change the depth of the player that the player is drawn on based on where the player is in the room? Here in the step event, what I can do, I'm going to do this right at the beginning. I'm going to set depth, which is a built-in variable, equal to minus y. What that means is whatever the y position is in the room, say the y position is 100, the depth will be minus 100. If the y position is, I don't know, minus 100, then the depth will be 100. And in doing this, as the player moves up the room, they're going to be drawn farther and farther back, okay, or lower and lower in the pile. So this value will change depending on the y-coordinate of the player. The depth will change. Let's take a look at our grass. In order to make use of this idea, I want to do a similar thing with any sort of shrubbery or object that I place out in the room that I want the player to sometimes appear in front of and sometimes appear behind. So here on my grass object, in the create event, I'm going to set its depth equal to minus y, the same idea, minus 10. Now what that is going to do, the grass doesn't move, so I'm just setting its depth. It's going to stay at that depth. But it's going to use its y position, the negative of its y position, and it's going to subtract 10. And by subtracting 10, I'm just making sure that it's not going to be on the same depth as our player at that same y. Let me show you what happens. Now I come out. Here's my player. If I move over here, I'm now in front of the plant. If I move up a little, it's kind of hard to see. Now I'm behind that plant, in front of it. Here you can see I'm behind them all. It's got a big clump of them going out here. You can see that I can be sort of in the middle of those plants. Pretty cool, huh? So in front of some of them and behind some of them. So it now looks a little more like I'm actually sort of living inside that world. We could do the same thing with the tree. In fact, it's probably already set up. It is. So since this tree has already been set up for us, and we've now are updating our player's Y based on where the player is, now when I walk up to this tree, here I'm in front of it, now I'm behind it. Very cool. All right, that's it for this lesson. We learned a whole bunch. We learned about finite state machines, and we learned how to fix the collision mask and use one collision mask across all sprites on an object, and we learned how to alter the depth of our player in relationship to other objects inside the room.